Hello viewers, in this video we have to learn about a concept terminal velocity related to a falling object. Terminal velocity, that is the velocity remains constant. It means no longer accelerating or decelerating an object. For an easy understanding, we discuss this concept with an example and finally made a quick summarize in this video. As the example, consider somebody just kept out of airplane in air. At the instantaneous time, the person become in stationary at air. As the person having a mass, gravity pulling him downwards towards the earth with a feel of weight. As the person's mass doesn't change, the magnitude of weight in over the period is same. That means the size of the weight arrow is same size in this video. Now, in this instance, the weight is the yearning force acting on the person. The resultant force, which remember the combination of all the force acting on object is the same amount of weight as no other forces acting on object. Due to this resultant force, the person accelerated downwards. Since as the person started to falling, should be considered the account of air resistance which acting upwards. That is, it acts opposite to weight. The air resistance, sometimes called as a drag, the collisions between the person and over the tiny air particle they met at air. Ineffectively, as the person falls, collision of tiny particle slows the falling speed. The size of the air resistance is depends on number of collision occur on the person falling. How many number of these like collision is possible? It depends on two parameters: surface area and velocity attained by an object. So surface area of over the head and shoulder. The higher the surface area, the larger the area over which collision can take place. Similarly, the velocity of an object, the faster they are moving, the more particles they will collide with. At the instant of the object or the person falling down, it won't have accelerated much, and hence velocity will be low. Hence, the corresponding air resistance which acting upwards become low. The resultant force as sum of weight and air resistance both acting in opposite direction, so air resistance just cancel the downward force as it equal level. So the size of the resultant force is reduced, but it still acting towards the downward. As the person accelerated downwards, the falling velocity increases continuously. So this is increase the air resistance further as due to there is no change in the mass. The resultant force decreases. The rate of acceleration will fall. In order to understand, consider the time velocity graph as the time is taken in the x-axis and velocity taken in the y-axis. The curve it gets less steepen due to the rate of change of acceleration is decreasing. Person are reaching at the higher velocity, the magnitude of air resistance is equal the magnitude of the weight. That means the size of the air resistance arrow is equivalent to the size of the arrow of the weight. The resultant force becomes zero. So this means no more acceleration. The velocity becomes constant from this moment. So this constant velocity is called terminal velocity of falling object. As the quick summary, when an object is started to falling down, the resultant force it only depends on the weight. It's simply the force acting towards the downwards. Velocity of downwards it's increasing further. When velocity increases, the corresponding air resistance is in opposite direction is also rises. At one stage, the magnitude of the air resistance is equal to the magnitude of the weight. It's both become in opposite direction to balance to each other. So on this junction, the resultant force becomes zero. There no more acceleration. So the corresponding constant velocity is called terminal velocity of an falling object.